The same setup, and using that coil, and it's just hooked up to 120 volts mains, the staccato interrupter hooked up to it. I haven't dialed it in perfectly, but I've got dialed in enough to play with the angle a little bit, so cut it up. So this is about 120, dialed way off. See, it started arcing there. It's too close. Let's try that again. I actually need to be able to adjust that knob a little bit further over. When I brought it as far over to the left as I could, what I heard was towards the end some primary strikes. I just couldn't see them because they were happening on the other side of the coil, but I know what they sound like, so I know that's what was happening. So arcs got longer and longer and longer, and eventually it got to the point where it's just the way that top load is and the way that breakout point is, just started to streak over. What's that, about 180 kilohertz? So running a little higher than I originally thought, because when I first was running it, I had this metal plate sitting right here to shield my driver. It was so close to it, dropped it by like 20 kilohertz. So what would be the difference? 120 staccato, taking that top load off, running it closer to like 250 or something like that. Is it going to be enough of a difference to try to say it'd be more appealing to running at the higher frequency? Basically, those aren't crazy long arcs or anything. I mean, they're getting pretty close to the length of the whole setup. Hoping, you know, if I was to use that coil, tuning around with it some, then yeah, I can get better output. But from what it looks like, based upon the length of those arcs, it seems like if I was to crank it up at the same voltage, 120 VAC, at either half wave or full wave, unsmooth, continuous wave, then that's pretty much what it would look like. About that, you know, some bush that spits out, it comes out to about that length. So here's no top load, sort of got it dialed in close enough. If I cut that up, you can see if I bring it up to like only like 75 volts, it starts to look like it's going to be sort of sword-like. Or you could still sort of shape it to a sword. .260 kilohertz, which is what's this running at. You do lose the swords. They still kind of go upward, but they're not swords anymore. Unless you get low voltage like that. And then when I change the phase again, it starts branching some more. To hear the different sounds the art can take on, it gets a little confusing just listening to it. What's the most healthy, I guess you could say, but just by upping the frequency, something like 80 kilohertz, it really didn't make enough of a difference to where they're really more sword-like. So I might as well just throw the top load back on and run it like that at the lower frequency. Monitor the current draw here. So we're at about 25 VAC only, and drawing a little over half an amp with this particular phase angle. Still get output, actually get output all the way pretty far. So I've got a poor tuning on this thing. Basically, this is a tuning where it's really not pulling a lot of power. This is a black light, by the way, and as I get closer to it, so really not pulling anything until I start pulling that arc, as you can see. So when I start pulling the arc, pulling that steady arc stabilizes about 2 amps, and as I draw close about to pull the arc, we start bumping up. All the way to over 3 amps before it actually pulls the arc. And then again sort of levels out as I'm pulling it. Now I'm going to adjust that phase angle to where as I'm bumping this up, it's going to increase the power. You see eventually that little light right there comes on, still 25 VAC. So now I'll bump it up just a little bit. I see more output, pull a little more power. So you see now I start pulling all the way up to about 6 amps before I start pulling an arc. And again, my lights start dimming a little bit. I can start pulling all the way up to about 6 amps before I start pulling an arc. So that is to say, if I was to crank the voltage up really high with that phase angle, it's going to pull an insane amount of current and everything's going to get real hot until I actually pull a steady load from it. So that's just kind of how that works. So I'm going to try changing it around again. I'm turning it left, so let's just say I'm on the left side of the hump now. I'm on the left side of being detuned. Now I'm going to shift it to the other way. So I've reached a peak. I keep turning and it's shifting back down. I'm losing output again. So now I'm like on the other side of being detuned and pulling a steady about 3 amps damn near. And as I get closer to it, hardly any output at all. Pulling some high current, get close to it, pulls hardly nothing, and it doesn't want to put out any power, any kind of arc or anything. It's real weak. So it seems like the ideal tuning would be on this side of the hump, pretty far over. All right. Finding some type of reasonable in between. So see, what I'm doing is I'm just cutting the voltage up until it starts arcing. If I don't let it arc over like that, it's probably going to start pulling a lot. So let me see. I'm going to start cutting it up. And I had a real bad flashover on the secondary, so hopefully that didn't burn anything. But it actually wasn't pulling too much power in that setting. See how it arced over? So I'm not going to let it keep doing that. That was actually a couple pretty violent flashovers in the same spot, but I can't visibly see any damage to that thing. But yeah, the secondary is already a little bit warm there just from doing that. So I don't think that secondary would be too happy pulling continuous wave like that. Anyway, what I learned from this is, it seems to me that that kind of phase angle is typically what I'll see in other circuits. So that is to say, there's a particular phase angle to where it looks like you have real good output, but it's pulling an insane amount of power. So when you start cranking it all the way up, it's like the only way to get away with that is to pull a load. Or likewise, I can detune it to about the point where it's at now, crank it all the way up, and get some type of output that's manageable. It doesn't pull too much current, and it looks about what I normally see on the other circuits. Need a way bigger heatsink, but This actually sort of seems like a bootleg way to power limit. If I wanted to actually run that continuous wave just the way it is, just tune that phase that going like that, cut it all the way up, still be able to pull hot arcs.